If we fold a rectangle about its one of the diagonals, then we can obtain a pentagon. Then what will be the ratio of the area of the pentagon to the area of the rectangle? Hi students, this is Deepan here. I'm a faculty here in Cheenta. Let's understand this concept through a problem which has been asked in Australian math competition in the senior section 2020. So let's get into the problem. So this is the question. In the question, it is asked a rectangular sheet of paper that is 3 times as tall as it is wide is folded along one diagonal, making the pentagon shown. Okay, so this is the thing, and we need to find the area of this pentagon to the area of the rectangle. Let's understand the problem practically, how it actually works. So this is the rectangle whose length is 3 times of its breadth. So now let's draw the diagonal just to fold it. This is the diagonal of the rectangle, and let's fold it by the diagonal. So this is the pentagon that mentioned in the question, and these are the points. It may felt like these are the midpoints of the corresponding sides, but they are not necessarily, and they won't be actually. If you just do it practically by yourself, you can also observe they are not the midpoint of the corresponding sides. They don't need it to be, and you can see through the solution it won't be. So let's draw the diagram here, the thing we need. So for example, if we just first start with a rectangle like this, whose length, for example, let's say, breadth is x. So this has to be 3x. Similarly here, 3x. Now area of this has to be 3x square. Now, if we look into the diagram, we need to draw a diagonal, this diagonal. So this has to be this portion 3x square upon 2, 3x square upon 2, because we know a diagonal of a rectangle divides into 2 triangles of equal area for obvious reasons. Now, if I now fold as we discussed, then we will obtain a picture like this. It's kind of a butterfly picture. So if I name this rectangle as, let's say, A, B, C and D, then this has to be A, this would be my B. Now look into this. C will be folded and will appear here. So this is my C and this by D. So before we move further, let's gather the information we can have. For example, length of the diagonal. The length of the diagonal would be, using Pythagoras theorem, we can directly find square root of 3x squared plus x squared, which will give us root over 9x squared plus x squared, which is 10x squared. So we'll end up at x root 10. This is the length of the diagonal. Okay, so AB is x. So let's focus on this point, this point. And if we draw a perpendicular from that to the BD, it's a perpendicular. Let's name this point as E and F. Now, what is required here? Let's first understand that how can I get the area of the pentagon. So if I compare this with this, So I know the area of ABD, which is this, and obviously VCD as well. I know that. But if I just add them, I won't get the area of the pentagon because this portion is been counted twice. So if I just add these two and subtract this portion, then I'm done. So the question is now about what is the area of BED, triangle BED. So for triangle BED, I need the BD. I know the BD, which is x root 10. Now I need to know the height of the triangle, which is EF. Let's try to find that. And if we focus here, these are the 90-degree angles. So these are two right angle triangles. Now let's try to focus whether they are similar or not. So now I'm talking about triangle BFE and triangle BCD. Definitely angle F is equal to angle C, which is 90 degree. And secondly, angle FBE is equal to angle DBC. Obvious, they are the same angles. So by AA criterion, we can say these two triangles are similar. Okay, so the first conclusion we can have is a ratio of these two similar triangles, ratio of the corresponding sides of these two similar triangles has to be equal. So let's use that. For example, BF. Okay, our target is EF. So BF is correspond to here with BC. Now let's go to EF. EF will correspond to here DC. Let's try to get something out of it, or let's complete this, and the third side would be VE will correspond here with BD. Okay, so from this onwards we will try to figure out the known things. Let's take these two ratios. So BF, let's figure out about BF. What is BF? So this is let's say theta. So this will be theta as well. So this is ADB. This is theta. That really means that this is an isosceles triangle, and I drop the perpendicular from the vertex to the non-congruent side. That means it's the median as well. So these two are equal. That means I knew BD is this, the length of the diagonal. So this is half of it. That means x root 10 by 2 by BC. What is BC? BC is 3x equals EF. That's what we want, by CD. CD is x. So this x and this x cancels. So we are getting our EF, the required thing. EF is x root 10 by 6. Okay, now we can easily find the area of BED, which is half times base. BD is x root 10 times the height EF, which is x root 10 by 6. We are ending at 10x squared upon 12, which is 5x squared upon 6. So we found the BED. Now, as we found the BED, that area of the pentagon ABDCE would be 3x squared by 2 plus 3x squared by 2 minus 5x squared by 6, which is 3x squared minus 5x squared by 6. If we simplify it, we will get 3 6 are 18 minus 5, 13 x squared by 6. So now we got everything. We know the area of the rectangle is 3x squared, and we found the area of the pentagon is 13x squared by 6. Now let me know in the comments what is the required ratio you are getting here. So I hope you guys enjoyed and understood the solution. This is a very efficient way to solve any geometrical questions related to triangles, the angle chasing and the properties of similar triangles. Hope to see you soon in the next video and continue to do good mathematics. Bye.